Hello everyone, this is my workshop 2 for Intro to Theory of Computation, and I created a PDA in Spiral Knights. First off, I'll show it off in JFlap and explain how it works. This time I won't explain too much about how Spiral Knights works. You can look for my original video for that. And then from there, I'll compare it to the DFA and then look at the alphabet and the language it works with. And then I'll look at the limitations of my PDA and then show off the C++ implementation. So this is the PDA that I ended up with, and I'll look at it in two halves because the first half of it will generate a level, and the second half is running through the levels it generates. So looking at the first half here, we start with a state called mSelect, and then we head to the build state. I place a $sign as like an arbitrary end of the line value, but once we're in the build state, we look for three different numbers, 1, 2, and 3, and that coincides with how the arcade game mode works in Spiral Knights. You can go down from the surface to the core of the planet, and it's divided into 3 tiers. And what this does here in each zigzag is it builds up the layout of levels in each tier. So it expects an input that goes backwards. If you want to start from the surface and go all the way through to the core, you would want to have your input say 3, 2, 1. But the game also gives you the option to start from tier 2 or tier 3 if you want. So in that case, it'll look for a 3 and then an F, or 3, 2, and F, F being the symbol that you want to stop generating levels early. And this could be greatly simplified if we were allowed to use multi-character input. But most of these states, I don't even name them because they will transition to each other automatically. And no input will be read until it reaches like the end of tier 3, the end of tier 2, or it's ready to start levels. Moving on to the second half, it's pretty similar to my original design. Things like attack, charge, shield, dash, and shield bash, they remain the same, but the transitions between level start and idle are different, and there's a new revive state. And I also changed up how you could get back to the start of a level from the dead state. And I had to account for reading the stack now. So at the start of a level, two things can happen. It does need to read an input N, but it'll then try to check to see if there's the letter D on the stack. And if that's the case, then that means the player was dead and their team reached the next level and they were brought along. I'm now able to implement the game's emergency revive system. And the way that works is you get 1 free revive every level. And then if you use it up and then die, you either have to use a premium item to revive, or your friends have to complete the level for you. If you do make it to the end of the level from a dead state, you'll still be dead on the next level, but you have the automatic revive to use again, so that'll be used up right away. Otherwise, if that did not happen, then it will just add a plus symbol to the stack to signify that you have an emergency revive. So now you can die about 1 or 2 times total per level run. Ooh, I didn't mean to go forward there. And one other thing that's different is if you're dead, I set it up so it needs to read a choice input, either return early or decide to continue when your team reaches the elevator. Otherwise, if you're alive, it'll look for the input E as the end of the level, and it'll check to see what's on the stack. If it's a plus symbol, it'll pop it off because we'll add a new one in the next one. Otherwise, once you get to that state, it will determine whether or not to force you to go to the next level. And that happens if the next level is a town, the last level, or a checkpoint level. If it's a normal level, then it'll need to read a uppercase N saying you want to continue, or you could give it an uppercase R at any point aside from these. And I think there might be some unnecessary lines here, but what I was trying to avoid is non-determinism. So I sort of always try to look at the stack and place stuff back if I have to. Otherwise, if it's something I can move, I will. And then we'll move on from here to the comparison. Like I said before, a lot of the action states a player can take remain completely unchanged. But now that we have a single-use emergency revive per level, I now look at the stack instead of waiting for an input character for reviving, and then transitioning between idle, level start, level end, return, and dead all work differently. And a lot of it's to avoid determinism, or not avoid, to keep determinism, or to just remove levels off the stack as we complete them. And there's a new revive state, and I use that to handle whether or not the player was dead before and needs to use their emergency revive right at the start of a level. And now we'll cover the alphabet for both the input and the stack. Most of it remains unchanged from my DFA, but I did remove the lowercase r for reviving, and I added 1, 2, 3, and F just for generating the levels. So if you'd like to, you can pause here and take a closer look at it, but I'll move on. Here is the alphabet that the stack uses. L, T, C, and E, they're all for different types of levels. It is interesting to point out that there are towns between every tier, and that sort of counts as a level because you can sometimes fight enemies and die in a town. So I had to leave it in with the rest. And then the $sign is my arbitrary, there are no more levels, so we need to do something here, or it won't accept the input. And then the plus symbol is the emergency revive, and then the D is used to determine whether or not the player is dead at the next level. All right, so now I'll cover the recognized languages. I split it up into two parts. The first part, X, are just the options we have for generating the levels, and this only happens one time. But Z handles everything else, which can repeat, but it has to happen once, but it can only repeat 29 times. At that point, we've reached the end of all the possible levels that can be done in one run. So looking at two different things that can happen with P sub A, these are all the actions the player can take. And then P sub K is any situation where the player ends up in the dead state. So Z will start with N, and that goes from level start to the idle state. And then first, let's assume they have their emergency revive. If that's the case, these are all the arrangements of input that can happen. But the general gist here is that you can only die twice. So you can do actions whenever, up until the point where you have died 2 times. So for the first few examples, the first 3 are cases where you die twice, and after that you need to move on and make a new decision. And then otherwise actions can keep happening, or we could just end there and continue on. And then this is also showing what it would look like if you start the level and immediately use your emergency revive. You can act up until you die once, and at that point you're stuck in the dead state until you move on from here. And then you can ignore these for now, they're slightly wrong, but what I will say is that, like in any case, either the input is you have the emergency revive or you don't, and that has to be based on the prior level. So if you weren't dead before, you could have your emergency revive, but if you're dead in the prior level, you will be without it in this one. And then we can concatenate the end of it with 4 things. If we have just an E, then that means the player was in a dead state, but they continue by choice or they're automatically pulled in. If they did not die, then that would mean the next level was a town, the end, or a checkpoint level. And at that point, it'll automatically force you to go on. If it's a normal level and the player is alive, then we're looking for E and N. And then if the player is alive but returns from a normal level, then it would be an R instead of an N. And then if the player is dead, we can just end off with an R and they choose to return. And then if we end off with an R here, then that'll be the last time we repeat Z. So now we'll move on to the improvements and limitations. My route of choice was to create a PDA that allows for greater complexity of the features Spiral Knights has. It now supports creating levels based on the arcade game mode. Levels are now finite, and I also included the variation of level types to include the nuance about whether or not you move on to the next level automatically or have a choice. And now that I know the context of levels, I can also keep track of the emergency revive. And I have the original DFA multiple times up here to symbolize that trying to handle levels before would require me to repeat the same general structure over and over again. So my PDA supports 29 levels. You could probably go back to a DFA, but there'd be 29 of these at max. So I'll still cover some of the limitations of a PDA for my case. I did not manage to implement health or shield health or anything like that. And the reason is that these values can increase and decrease in like random amounts depending on how much damage is done. And I think it sounds like something that requires a greater context of how much damage is done, how much your HP currently is, or shields. And if I were to simplify the health down to like single hit point damage systems, then I wouldn't be able to implement both health or shields because I would have to begin offloading the stack, all the symbols based on health and shields and likewise. And if I just chose one, I'd have to do it just to get to the emergency revive and the levels. So I had to call it quits at this point. And then the one other part of level design that I couldn't implement was anything not arcade based. The game has missions and prestige missions, and what those end up doing is they break the conventional rules of floors you start on. They throw you in a lobby, and then you can go out to any floor, not starting at the beginning of tier 3 or tier 2 or what have you. And then the amount of levels you complete vary from up to like 3 to 6 levels, depending on the mission. And every mission is unique, so I didn't want to try and implement every unique mission because that would create a very large PDA. And I'll splice in a video of exploring my C++ implementation here, and I'll also do a little walkthrough on the JFlap to see how they compare to each other. Okay, so here I have my C++ implementation. In main, I just have a Boolean function that'll return whether or not the machine accepts. It's called run PDA. It takes an input of my spiral length PDA and the string input, and it'll iterate through the string, feeding each character into the transition function, or it'll end early if it reaches an error state. So from there, I get an input, set up the PDA, and then get the output. Looking at my header file for it, I still use an enum for the states, and it now includes revived, start of tier 3, 2, 1, end of tier 3 and 2. And then on the public side is my constructor, the transition function, and the function to return whether or not it's in the accept state. And then internally, I think I managed to mostly implement it without non-determinism. It holds the current state. It has a stack from include stack, or not include string, include stack right here. And it takes characters, and that is the memory stack. And I just have a variable to hold the current input character that I popped, but I make use of a function on the stack called .top, which will let me read the top without removing it. So there's a function that'll determine whether or not it's a valid stack input. And then there's also a function just to handle the memory stack. So the transition to function still operates just with the input string, and I handle the memory on my own end. There's also a function to just load the levels by tier, and that greatly simplifies how many states we have to go through, because I have a lot of states that automatically are reached and automatically leave. And then I moved the state to string function that I had in my DFA into the class. And then I don't believe I used this function, but I started to try and implement a function for the reviving. So what's new here is I actually made use of the constructor. Since my PDA will automatically transition from the initial state before it reads an input, I do that myself. And I have an extra input symbol it can read, which is an uppercase G, and that's exclusive to my code for handling the automatic transitions that don't read input. So my transition to function, it'll let you know what the current state is and what symbol it's reading. I have a Boolean recurse, and whether or not that's true or false, I might recursively call this function again and pass it the uppercase G symbol. And then I have the main switch case based on the current state. For example, if we're in memory or mselect, then we will, I will push the $ onto the memory and then set the new state. And as you can see here, I call the transition here. So it'll automatically move on before it reads any input. And then after that, I'll start to have nested switch cases based on the input symbol. And for stuff like building, there's recursion that happens. It'll go to the start of a tier, these states, and from there on out, stuff will happen automatically. So I will set recurse to true. And then from here, it decides whether or not to read the next one. I'm looking for something else that's interesting. I feel like I cut a few corners in code. I wasn't sure how to implement an actual non-deterministic PDA. So I did everything I could to prevent that, including modifying my PDA. But this has been a very, very fun process, nevertheless. So for the case of lstart, this is where fun stuff starts to happen. I start to try to read what's on the stack without manipulating it. And then I also have to catch the case that the stack is empty. If you don't do that, then if you make a mistake, the code will break. But in this case, like I'm checking to see if the player needs to revive. And if they do, I'll handle transitioning automatically to the revive state and then to the idle. So I'll make a recursive call after that. Otherwise, the player might still be alive. So this was a spot that is two branches would be taken simultaneously in my PDA, but here I have to look ahead and make my decision before that. And then I also have messages to let you know when the player dies and uses a revive, or whether or not they can. And then another fun case, the first one is E from idle, I believe. No, from idle. I want to look ahead at the next memory first. So I also have to check to see what the current size of the memory stack is. I don't want undefined behavior, but what I end up doing is I check to see what's at the top of the stack. And the reason I do that is because there are situations where you must continue. So I want to automatically move to level start, but also keep in mind that maybe this isn't the case and it needs to read an input first. So this is another case of looking ahead, peeking at the stack, but not actually pushing off of it yet or popping off of it. And in the DFA, stuff like attack remains mostly the same, except I have the same code for determining whether or not the player will automatically revive or not. And if I get beyond this to some of the other changes, the dead state, maybe you want to return, it'll check to see if that's a decision you can make or not. And then if you continue, it checks to see if you can. And then level end works about the same way. And then assuming you get all the way through to the end, I'll list out the new state and then create a dividing line. And then at the very end, it checks to see if it should make a recursive call, and if so, it does. Moving on to the is accept state, you just return whether or not the current state is enum return. And then I also created a function that would let me evaluate the stack input, but I'm not sure if I use this a lot because I realized I could manage this on my own end rather than having to get the input from the user. And then handle memory stack was really fun. There are 3 things I wanted to look out for. The first one is the stack is empty. The second one is whether or not it reads the value that can be popped based on how PDAs work, and then whether or not it can push. So actually that is where validating its illegal stack input character happens. So I do use an extra character for the stack alphabet, and it's just 0. It's to signify do nothing, sort of like how the lambda shows up in JFlap. And then I have a lot of if cases. If it's an empty stack, then I want to let you know you can't pop any more values, and also lets you know whether or not you can pop symbols or push based on these cases. One moment. So I had a small cut there, sorry about that. But so I first make sure I can, it's not an empty stack, and it's a valid case of pushing or popping, and then I handle that. I try to pop values first, and then I also print out a statement letting us know what the stack size is and what it'll read next, partially for debugging and for following along with the PDA. And then my clever trick here, load level symbols. It's just a simple if statement. So instead of calling the transition function several times, I just load it all into the memory stack automatically. So you call this function and then you move to the proper state after that. State to string is just a switch case that converts the enum value into a string. Otherwise, we would have to read a numerical value. And then, yeah, I did not make use of this, but I will now run the code and see if we can follow along in my PDA. So it initializes the machine, and it does go through one state, and that's a sample of what the output looks like. So I'll follow the sample string that I have set up, and in the end, it is accepted. Though I don't think you would want to call it a longer run. That's a small error on my part, but we can redo this in the JFlap just to see what happens. So if I grab the string here and do the test case, input, step with closure, paste it in. So we can see here that it'll automatically transition, and then it will read the first value, which is a 3. And then without reading anything else, it reaches this state. And then you can see that happen here. So current state is build. It's reading the symbol 3. It'll first push E and then move here. And then I make the recursive call, so it reads G, and it has a small message here, loaded tier 3. The stack size is now 12. And I believe that is the same as what we have here. So now it's in situation where it'll read the next value. And if we do that, it reads 2, goes through it all again, and now it's at end of tier 2. And we have the same thing here. And now the stack size is 23. And the next thing it's looking for is a 1. And it does. And then it ends up with else start. So if I catch up here, go through this, and now we're at level start. It now has to read an N, which we do, reading symbol N. So it'll push the emergency revive onto the stack. And now we're in the idle state. And then we run through a normal action. We go attack and then back to idle. And then we shield bash and go back. And then let's have the situation where the player dies and it automatically revives them and they're back at idle. So if I follow along here, so from idle, the player dies. Before reading anything else, they get sent back to idle, but we remove the plus from the stack. And then what the input does here is it ends the level, we reach the elevator. So for here, it'll do that, and then the next symbol is an N. So it'll pop the next level off the stack, and that's now the level we are on. Now we're back at L start, and then we go back to idle. So let me catch up here. So now the next thing I show off in this string is dying twice. So in the code here, we can see that they revive, but in the second one, it does try to see if it can revive, but cannot pop. That is not currently at the top of the stack. Player has already used the emergency revive, so now they are officially in the dead state. So that happens here by reading the 2 Ks. So now we can either read an E or an R, and in my code we read an E. And what that does is it'll go to L start, and then we find out that the player died, it pops it off the stack, and the new state is now revived. And then I make the recursive call. We're now back in idle, but there is no plus on the stack. You can see that here. There's a bit of non-determinism that happens, but we're looking at it still being in the revived state. So currently we're looking at the one that's idle, which is here. This one is broken because there's the dead symbol still. But so going from there, we just go E and then R. So the one that jumped ahead early will fail, but if we continue, we reach our accept state. So that's how my code works. If I have to present a second time, then I will definitely create a version of it where you can run through it yourself and it'll give you the next symbols that it can read. But we'll cut back to the slides now. All right, moving on from that. That's all I have for my workshop. If you have any questions, please ask. And if you see any issues with the work I've done, please let me know. This got much more complicated than I expected. So I spent a lot of time revising it as I worked on my C++ implementation. So it wouldn't surprise me if there are still a few issues that I have in my PDA. But thanks for watching the video, and I'll see you.